Okay, so instead of working out the problems, what I've done is I've taken the teacher edition answer key to show you the answers, but I'm going to go through and try to explain and help you here. So in this first one, you're using mapping to determine the inverses, and then to determine whether the inverse is a function or not. So our original function is here, and all we do again is switch the x's and y's. So now our y becomes our x now becomes our y over here, and we just go through and fill in. This is a function because it is 1 to 1. Now all that means is for every input there's exactly one output. In other words, each x can only have one y, and we kind of talked about that with the vertical line test. So in number 2, the inverse is not a function because this x, 1, has two y's, negative 5 and negative 1. The same here with 9, has negative 3 and 3. So as we continue, it says write the inverse of the given function as a set of ordered pairs and then graph the inverse on the coordinate plane. So all they've done here, and we did this in the video, there's negative 4, it now becomes your y. Here's negative 3 as your y, it now becomes your x. So I've just switched those and then plotted the inverse points. Now, one of the things that you're going to notice, they have this dotted line here, which is the line y equals x. Whenever you do an inverse, that's what happens. You're switching your x's and y's. So where this was x, y, this now becomes y, x. Why? Because your y's and x's are switching places. So it's symmetric to this line, y equals x. In other words, it's flipped over that line. So again, we've done the same thing here. We've switched our values, plotted them on the graph, and again, it's symmetric to the line. You can go straight across and see the inverse function point. Continuing on, 5 and 6, it says find the inverse for the given function. So again, what we did here is we replaced our x with y and vice versa. So if our function is y equals 4x minus 8, what they're doing is they're solving it first and then switching x and y. And what we did in the video, and I'll work this one out by hand so you can see it a little bit better, but what we did in the video was like this. We said, okay, if y equals 4x minus 8, then, change colors here, you can see it. So now x equals 4y minus 8, and then we solve for y. So then we add 8 to both sides. So we get x plus 8 equals 4y. And then to get rid of the 4, we divide both sides by 4, and we end up with this, which is the same thing they did here. So again, it's what we talk about in math all the time, same thing in different ways. So again, you see what they've done over here. They've gotten basically the x by itself, and then they switch the x and y. Don't forget your inverse function notation. So let me expand this here again so you can see. So for 7 and 8, they've done something similar. So I'll just give you a minute here to look at that, check them. Okay, as we move on, question number 9. This a little smaller so we can get the graph in here. Find the inverse function for the given function. So what we've just been doing, it says use composition to verify that the functions are inverses, then graph the function and its inverse. So first we have a linear function. So the first thing I would do is graph it. So the function is graphed over here. Now how do we do that? Here's my y-intercept, which crosses at 3, which is right here. I have a slope of -3, so that means I go down 3 and over 1, and then draw my line. Next, I find the inverse. So again, you're switching your x and y, or do like they did, write it as y equals -3x plus 3, and then get x by itself. And then once you do that, make this your x, and that becomes your inverse. So how do we graph this? Again, there's our y-intercept is at 1. And then we go down 1, and then to the right 3, and then there becomes our inverse line. And again, it's flipped over this. So if you take this portion right here, which is the inverse, it's symmetric to this portion. In other words, it's flipped across that line. Same thing here with this portion. Now, to verify or check, remember that you have to do the composition twice. So you got to do f of g of x and g of f of x. Now, they use inverse of f of x and then function of f of inverse. Again, it's the same kind of thing. So what we're doing is we're taking f of x, which is -3x minus or plus 3, and we're putting that into the inverse function, which is this. So I'm taking all of this and substituting that for the x here. So that's where we get -1/3 instead of times x. We're putting this in. We simplify, so we do distributive here. We end up with x minus 1 plus 1. The ones cancel. We end up with x, which is what should happen. Same thing here, except we switch. Now we're taking the inverse and we're plugging it in for x in the function. So we're plugging it in right here. So again, do distributive. We do that, we get x minus 3 plus 3. Again, the 3's cancel and we're just left with x. So it's a good problem to look at to see how you do the composition, but make sure you do it both ways. Again, we did it a little different notation on the video, but same thing we talk about math, same thing in different ways. So what I'm going to do is I'm going to slide up number 10 and give you a second here where you can check. If you need to, pause the video so that you can see it and look at the work. Okay, so we're almost done. So now we're in problem number 11. So it says here, for the given function, determine the domain of the inverse function. Okay, domain of the inverse. Okay, that's important. Find an equation for the inverse function and graph it. Interpret the meaning of the inverse. So we have an equation, a equals 1/2 20h, gives the area of a triangle with a base of 20 inches as a function of its height h. So here's our equation. So you can think of big A as y and little h as x. So again, what they've done here is they've solved for h, and then they've just flip-flopped the h and the a over here. Again, you can do it however you want to. This is kind of how the textbook does it. As far as the domain goes, whenever you're talking about in geometry or any kind of real-life situation, a lot of times you're going to find that graphs can only occur in the quadrant 1 because you got to have positive values. Well, the case is true here. Even for the inverse, okay, you can't have a negative height, you can't have a negative area. Okay, so the inverse function gives the height of a triangle with a base of 20 as a function of the area. So if you go back to and read the domain for this, the domain for area is all values greater than 0. Okay, could be equal to 0, because if you had a height of 0, then you would have an area that's 0. The same would be true here. If you had an area that was 0, then you would have a height of 0. So again, conceptually, the inverse should make sense. On the graph, we have an arrow just on this end because it can keep getting bigger this way. Here it is a point because you can't have, again, a negative value, so it ends at 0. Problem number 12. The label on a gallon of paint says it will cover from 250 square feet to 450 square feet, depending on the surface that is being painted. So if you notice, this is supposed to be the graph of the inverse. This was for what? This was the domain for the original function. So now what's happened? It now becomes the range for our new function. So that's why it goes from here 250 up to here 450. A painter has 12 gallons of paint on hand. The equation A equals 12C gives the area that 12 gallons of paint will cover if applied at a coverage rate of C. So again, we do the inverse. So they get C by itself here, and then they switch the C into A. And if you notice, as far as area goes, if you have, again, 250, which was our domain up here, you put 250 in, you get 3,000 square feet, which is right here now, which now becomes our domain. And you plug 450 in, which is 5,400 square feet, which is here. So all that's happened is now C becomes our Y, A becomes our X. So if you graph the original and put in those values, then all you're doing is flipping those on the graph. The graph of a function is given. Tell whether the function's inverse is a function and explain your reasoning. If the inverse is not a function, tell how can you restrict the domain of the function so that the inverse is a function. Okay, so it says the function's inverse is not a function because the function is many to 1. In other words, it's not 1 to 1. 1x does not have 1y. Now, how is that the case? What you can do when you're doing the inverse, it says the graph of a function is given. So what's going to happen, I'm going to try to draw this here, what would happen to the inverse? What would the inverse look like? Well, remember, the inverse is reflected over this line right here. Okay, I know that's not very clear, but that's the line y equals x. So what happens? This right here gets flipped over, so change colors. It now goes down here. That becomes the inverse function. Okay, if you draw a vertical line, it now touches at 2 points. So it doesn't pass the vertical line test. The inverse function does not. Another way to do this, so I'll get rid of all my marks here, is what is known as a horizontal line test for the inverse. So what does that mean? If you take the original function and you draw a horizontal line and it touches at more than 1 point, then that means the inverse will not be a function. It will not be 1 to 1. So there are two different ways you can look at that and determine whether or not the inverse is a function. So I'm going to do the horizontal line test on number 14 here. So on number 14, I'm going to take the original function, and I draw horizontal lines, and every time I do, I'm only touching it at one particular point. So therefore, the function's inverse is also a function, because as I do horizontal lines, it only touches it at 1 point. Alright, last problem, number 15. Identify the domain intervals over which the inverse of the graphed function is also a function. Select all that apply. Okay, what does that mean? Identify the domain intervals over which the inverse of the graphed function is also a function. Okay, so let's take the first one, 4 to positive infinity. So if I go from 4 to positive infinity here, and I do the inverse, okay? So again, you're trying to identify which ones would be a function. So you can do this horizontal line test just on that part, and how many times does it hit it? It only hits it 1 time each time. Therefore, it would be a function. So in doing this, that's why A is a choice. Okay. Now, let's try again for, so I'll erase that one. Let's try for B, 0 to positive infinity. Okay, so here's 0, and we go to positive infinity. That means I go down here and then go here. Well, the real point I need to check is when x is 0. So when x is 0, I draw a horizontal line, okay, and right here, it looks like it hits 2 points. But technically it doesn't, and here's why. Because we're not including 0. So actually, we're from here over. So in this portion right here, the only value of the function is this stuff down here. So it really never hits 2 points because at 0, it's not touching that point. So we're okay. So that one works. So you just kind of continue this process here. So let's talk about why C doesn't work. We go from -4 to positive infinity. That means we have to start from here on the X and move to the right. So again, I draw a horizontal line. Here I only hit 1 point until I get all the way across. And now I hit another point here. Because I hit 2 points, again, the inverse would not be a function. So we're not talking about the original being a function. That's a vertical line test, but here the inverse doesn't work. So let's go back then, and let's check out the others that did work. So let's talk about F, -infinity to 4. So if we go from -infinity to +4, that means all of this portion right here is not included because it's 4 on. And because it's non-inclusive of 4 here, then all I'm doing is this part right here. And every time I only hit it 1 time. So that works. G is from 4 to 8. So here's 4. Here's 8. So draw it here. And again, I only hit it 1 time. So the inverse works there. And then the last one is H. From 8 to positive infinity. So from 8 on, well, I'm just going from here on. Since it has an arrow, it's going straight up. It'll only hit it 1 time. So hopefully that horizontal line test kind of makes sense to you here. I know it wasn't on the video, but hopefully you have some clarification as to looking at a graph of the original function and how to determine if its inverse is a function.